So Hydrates, part 2. This is just some other ways that the questions can be asked to see if you get what the hydrates are all about. So I have this iron 3 chloride. Maybe you can see the bottle. It's kind of this orangish stuff. If you looked at it, you're not going to think there's water in it, right? It's orange. So anyway, we have this iron 3 chloride, and we know it's a hydrate. Somebody tells you, hey, I've got this hydrate. And we heat it to a constant mass. Okay, so that means we put it in an evaporating dish, and maybe we put it in an oven, and we heat it until the mass doesn't change anymore. So this data, I've only given you 2 pieces of data. It says, what's the formula of the hydrate? Right, that's the question. I'm going to call that, let's say, question 3. What is the formula of the hydrate? Now your initial mass, that's the iron 3 chloride hydrate, the question mark H2O I wrote, question mark, is 8.34 grams. Now your data really might look something like 5.25, 5.12, 5.00, 5.00. Okay, that's really what your data is going to look like as you kind of take it off and you find the mass, depending on if you take it off early or if you just wait a really long time anyway. Anyway, you're going to need those 2 data points. You're going to need to say, hey, I know that I heated it more and the mass didn't change. I'm showing that. But I'm just going to get rid of that because this is a question you might be asked in a textbook. And I know that that is the mass of iron 3 chloride. Okay, I have 5.00 grams of iron 3 chloride, and I know this 8.34 grams has some water in it. Okay, so here is your molar mass of iron 3 chloride. We get 162.20. Okay, so really big thing in chemistry is you're going to need mole ratios. When we look at hydrates, the one I looked at in part 1 was Ca. It was a dihydrate. So this right here is a mole ratio. This is saying there's 2 moles of hydrogen for every mole of calcium chloride. If you're talking about small units, there's 2 molecules of, did I say hydrogen or water? 2 molecules of water, right? 2 moles of water or 2 molecules of water for every formula unit of CaCl2 or for every mole of CaCl2. It depends if you're talking about small things or big things. So we need mole ratios. So one question that you're going to answer is, how many moles of anhydrous salt are you left with? And we have 5 grams, and we know the formula. That means we can convert to moles. Okay, we'll do that. Okay, 0.030826. Don't round this. Be careful. Sometimes you see a really small number and you tend to want to round it. Make sure you keep plenty of sig figs. I would keep at least 3, but I wrote 5 there because it's kind of not going to matter in the end. I'm not going to be using that number. I'm going to need that number. How many moles of water? So we got moles of anhydrous salt. Now I need to figure out B, how many moles of water? And if I know this is what I started with and this is what I ended with, then the difference between these must be the amount of water. So the difference is just the 8.34. I don't know why I'm writing this out. It's 3.34. Right, so 3.34 grams of water. But like so many things in chemistry, we don't want a mass ratio. What we want is a mole ratio. Okay, 0.18535 moles of H2O. So now we have a ratio. You can kind of see what it is. Just I think 0.03 compared to 0.18. You can pretty well see the ratio. But let's go ahead and divide by the smaller number so we can get some whole numbers. All right, this one comes out to be 6.01 to 1. That is very close to just a whole number 6. So the formula for the hydrate, right, or what this says, we have 6 moles of water for every 1 mole of iron 3 chloride. So the question is, what was the formula of the hydrate? And it would be this. Okay. There's that 6 from down here. It's a 6 to 1 mole ratio of water to the anhydrous salt, and we would call this iron 3 chloride hexahydrate.